Today we started with the direct line system. Any doubt in that? It's quite straightforward, quite simple layout of the pipelines, very commonly used on board crude carriers. Most of the ships they have this system. This diagram is showing two groups. There you have three or maximum four groups. VLCCs and all sometimes they do come across four groups. Otherwise, most of the ships they have three groups like that, three 4.5 line pipelines laid down at the bottom, and those pipelines are connected to different group of cargo tanks, and they are connected to each other also with the crossovers. That is bottom crossovers, known as bottom crossovers. They are also connected in the pump room on the suction side with the crossovers, known as, keep your audio off please, thank you, known as pump crossovers. They are also connected to each other on the discharge side. They are known as discharge crossovers. And at the manifold also, all these pipelines are connected to each other, known as manifold crossovers. Abhishek, your audio is on. Abhishek. So that's how the pipeline layout is done as far as direct main is concerned, direct line system is concerned. One of the simplest form of pipeline diagram, pipeline layout on tankers, straightforward, less friction. There's not too many valves involved, not too many pipes involved. That's just a direct system directly connected to the pumps. And the system is for bulk discharging. For stripping and all, we'll be going through the later. Less chances of making a mistake, but you cannot carry too many grades in this kind of pipeline layout. That's why it is very common pipeline arrangement on crude carriers, because crude carriers most of the time they're carrying single grade, maximum two or maximum three grades. Rarely they carry three grades. Not so expensive, easy to do the maintenance, as there are not too many connections, too many valves or something that, so malfunction also is less, easy to understand, very easy for discharging the cargo. In addition to that, what I have mentioned, which is not shown in this diagram, are the suction crossovers here in the pump room, also known as pump room crossovers. There's a discharge crossovers, and there are manifold crossovers connecting all the lines together. So in case if you have only one manifold connected to the shore, other group can also be discharged through the same manifold. That's why there are connection. If some pumps goes bad, suppose one of the pump is not working, the cargo still can be discharged through the other pumps using the crossovers. This is direct line system. Another system which is another very known among the product carriers is the ring main system. Is nothing but direct system combined together, connected together. And in addition to that, direct line system connected to that together makes a ring. That's why it's called a ring. Making a rectangle or connected together, that's why it's circular. That's why it's called ring main. If you look at the diagram on the left side of the screen, tank only, forward side of the tank, and this is the after side. Pump room is somewhere in the middle. You can put the pump room in the after also, doesn't matter. There is one pipeline in the 4.5 direction in a longitudinal form on the port side, and another one on the starboard side, and they're connected together with the crossovers, forming a rectangle or a loop. That's why it's called ring main. Basically, it is a one direct line and second direct line connected together to form a ring, form a closed circuit. In addition to that, if you look at one port, this particular tank, and rest all are the same. There's one pipeline going from this tank to the pump room. This is the pump room connected to the pump in a direct line system, and another line to the starboard side again connected to the pump here in the pump room. If you look at one port, there is one bell mouth in one port connected to the port side pipeline, and there is one more bell mouth connected to from the one port connected to the starboard side pipeline. So there are two bell mouths. So that means one port can be discharged from using the port, or can also be through the starboard side line, so that a proper segregation can be maintained. So there's a lot of permutation combination you can discharge from using this crossover also. Putting the oil on the starboard side of the pipeline, one port, I'm talking about one port only, and rest all are same. It has a different two bell mouths in each tank. The ship is divided into, on the extreme starboard side and extreme port side there are ballast tanks, and center part is divided with a centerline bulkhead, longitudinal bulkhead, into port and starboard tank. And each tank has two bell mounts, two ways of discharging, very commonly used in product carriers, product tankers, where they are carrying various type of grades and proper segregation needs to be maintained. Very expensive vessel because there are a lot of pipelines, a lot of valves are involved. Segregation of the different grades can be maintained easily on these ships. If you look at the another diagram here, this is also ring main. Each tank has its own bell mouth with the crossovers, and they are also connected. Various crossovers are also there. So too many pipelines. One port I can discharge from port side, I can discharge from starboard side, and it is forming the ring since they are all connected, making it a rectangle kind of a thing, closed loop. But basically, if you look at it, there are 2-3 direct line arrangement connected together so as to maintain proper segregation so that they can carry various different grades and maintain proper segregation without any contamination. Various crossover, there are too many valves you can see in the line. So many pipelines are used. There's a lot of ways of discharging one tank from different ways. You can use port side line, you can use starboard side line, you can use the middle also if you connect it. You can use connect it from here also. Each tank has various ways of discharging so as to maintain a proper segregation. Some of the chemical tankers also use this system, but most of the chemical tankers, they have a independent system. As I mentioned yesterday, they have their own pump, they have their own loading pipeline, discharging pipeline, stripping system. But in the ring main, all pipelines are connected together with the various pipes, with the various crossovers. There are many pipelines also installed on the main line so that the segregation can be maintained, so that products should not come in contact with each other. As you can see, too many valves are installed, too many pipelines are installed, becomes expensive, difficult to monitor. The chances of making mistakes are high. Ships are expensive, can carry various grades with the proper segregation. These are the advantages and disadvantages of ring main. These are bell mouths marked with the bell. These are tank valves marked with this is a master valves and marked with the cross with the crossover valves. Not easy to operate, but proper segregation can be maintained. Product carriers, very common on product carriers. If you look at the other diagram on this right hand side of the screen, there are 3 cargo tanks, port, center and starboard. Again, there is a ring arrangement here, 2 direct pipeline system connected together to form a ring. If you look at the one port and one center and one starboard tank, there are one bell mouth on the port side, one bell mouth on the starboard side, and center tank has 2 bell mouths. But there are 2 pumps only connected. One is connected to the starboard side pipeline and one is connected to this port side pipeline. If you look at the diagram, there are 2 bell mouths on the center tank. So in addition to this ring main, you can see one more line at the center which has own bell mouths connected to each tank, port, center and starboard. That is stripping line. This is a small diameter line. The main pumps and the main pipelines are used for bulk discharging, and this small pipeline, small diameter pipeline which is connected to the stripping pump, a positive displacement pump used for stripping the line, the last bit which is remaining in the tank. This pump is used for to take out the last bit remaining in the tank to discharge. It's a sure different type of pipeline diagram, but basically if you look at the diagrams, they are basically direct system connected together with the extra pipes, with the extra valves, so as to maintain proper segregation and design. The vessel is designed to carry various grades on board, commonly used in product carriers. So these are 2 different diagrams used in the ring mains. Ring main, somewhat like modern tanker, direct, no flexibility, used on product and some chemical tankers also they use this, but most of the chemical tankers they are using the submerged pump. Can use other type of pump, but the piping work is high. As you can see in the diagram, piping work is quite high, which makes it expensive, and the valves are installed in the pipeline to make sure a proper segregation can be maintained among the different. It is also called circular system. Any question understanding these diagrams? before I proceed on the PPTs. Okay, so it is also called circular system. This type of piping system provide for the handling of several different type of oils, several different types of grades. A particular tank can be pumped out either by the direct suction or through another line by use of the crossover. The system is very versatile. There's a lot of ways you can discharge. The system is very versatile, easy to maintain the segregation, good for the charter party, good for the ship owners to maintain proper segregation among different grades. Very versatile in the sense there are a lot of permutation combination, there are different ways of loading and also for the discharging. It is generally of a square or a circular layout. It is used mostly on product tankers as segregation of the cargo is required. System is expensive because more pipes and extra valves are used. However, that's why the freight is also high for the product carriers. However, if the vessel is carrying many grades of the cargo, the advantages compensate for the extra cost of original outlay. Disadvantages over the direct main is line washing is more difficult since there is no circular system and the washing must be flushed into the tank. The system has a fewer valves which makes pipeline leak difficult to control. As the system lacks versatility, there is a problem with the line and the valve segregation. This is talking about the direct main. So these are the advantages and disadvantages of ring main. Third system, which is rare, third system of the pipeline is very rare, that is called free flow method. It's used on a very large crude carrier only, or mainly on a storage tanker. Not so common. Low building cost, less maintenance. What happens in this? Why it's called free flow? If you look at this diagram, I can explain it in a proper way using this diagram. If you remove all this in a free flow, what happens? There's no pipeline here. Only the pipeline is installed on the last set of tanks and is connected to the pump room, and you have the manifold for discharge. And these pipelines are non-existing. There's no pipeline on any of the cargo tank. There's no bell mouth. So just imagine there's only pipeline on last set. This pipeline is existing, and there's a pump room and there's a manifold. There are no pipeline forward of this tank. Number 5 forward, there is no pipelines at all. Instead of the pipeline, they have installed a gate valve on the bulkheads, on the common bulkheads between the tanks in a fore and aft direction. They have installed a gate valve. So when I open this gate valve, the oil from this cargo, this tank, will flow to port. If I open the gate valve here, this bulkhead, the cargo from 2 port will flow to 3 port, give a stern trim. Same way from 3 to 4 it will flow, and from 4 to 5 because of the gate valves installed in the bulkheads. And the 5 port, there are pipelines, there's a bell mouth, there's a suction valve, and which is connected to the pump and which is connected to the manifold for discharging. So by gravity, the oil flows from oil tanks, all the tanks flows aft to the aftermost tank, and from there the cargo is discharged through the pumps to the shore facility. And same system will be there on the center tank. Instead of the pipes, you will have a gate valve installed on the bulkheads, common bulkheads among the center tanks, and by gravity the cargo will flow from one tank to the other, giving the stern trim. And once it reaches the last tank, which is connected to the where the pipes are installed, which is connected to the pumps, and the pumps can be used to discharge the oil to the shore side. And same is there on the starboard side. The oil is flowing by gravity, giving the stern trim, and it is flowing just there is a only gate valve installed among the bulkheads. Just open the gate valve. By gravity, the oil will flow from here to 1, from 1 to 2, 3 to 4, and finally to 5 by gravity. Free flow. And from 5, we use the pipelines, bell mouth, and then use the pump to discharge the oil to the shore facility. This is the free flow method. Less number of pipes. You cannot carry too many grades. Usually used on storage tanks, FPSOs and all. Less maintenance, easy discharging, not too many valves, not too many pipes installed in the system. Vessel designed mainly carrying one grade only. designed to carry one grade of cargo. Not very versatile. You cannot do much. There's only one way to discharge, not too many options available. If there's a problem on the gate valve, it gets difficult for discharging as well as loading. If suppose the gate valve is not opening or the spindle which is coming all the way to the deck, it breaks. Less maintenance as there are very few pipelines or valves involved in the system, and relaxed discharging, relaxed operation. Mainly used on a storage tanker or very large crude carrier. Advantage, disadvantage: low building costs, less maintenance, relaxed discharging. Disadvantages: simultaneous operation not possible if the gate valve fails or leak, no flexibility, topping off when you start loading, also the loading all the tank at the same time, problem in stripping the difficult cargoes. There's a separate stripping lines are also installed. Integrity of the vessel at stake, cannot carry multiple grades. So these are the integrity of the vessel at stake. Means suppose the forward tanks are all empty, the only cargo remaining in the aftermost tank, the stresses also becomes very high, trim becomes too much, there's no measures to control that, so integrity of the vessel is at stake. Vessel going through various stages and then going through various stresses. So these are the three systems used, pipeline system used on tankers. Other than that, you have stripping system. If you look at this diagram, yellow color is a main suction which is connected to the main cargo pump. MCP stand for main cargo pump. And white color, they are small diameter line which is the stripping line, stripping suction connected to the stripping pump. So you have a separate pipeline arrangement for discharging through the main pump for bulk discharge, and you have a separate pump and separate suction valve and pipeline for stripping the line, stripping the tanks, the stripping pump. Earlier, we used to have this kind of arrangement on ships. We used to have a separate stripping pipeline arrangement and a separate main cargo discharging, bulk discharging arrangement. Main suction and stripping suction, not connected to each other. Here you can see this is one group, or this is number 2 pump, which is connected to 3 tanks, these 3 tanks, and another pump is here which is connected to other 3 sides. So it becomes a 2 groups. And you have 2 stripping pump. One is connected to the aftermost tanks and one is connected to the forward tanks. Too many pipeline, too many valves again. Now modern tankers, they have, instead of this, they have removed the full stripping pump, stripping pipelines. Instead, that they have connected the stripping suction to the main cargo pipeline. And main cargo pipeline is used for stripping also and used for bulk discharging also through the cargo pump, and for stripping we use the stripping pump. So number of pipes are reduced in this. This is the modern way of doing that. Instead of stripping pump, we use the inductor. That's how the inductor functions. Anybody volunteer how the inductor works? Those who have worked on the tankers?
It works like a Venturi effect.
Venturi.
Diameter of the pipeline reduces, its velocity increases, because of which there is a pressure drop. And because of that pressure drop, it creates a suction effect. So if at the small diameter area there is a pipeline which is submerged in a liquid, it will suck up the liquid and carry it at the output along with the driving fluid.
Excellent. That's how this works on a Bernoulli's theorem. We have explained it very nicely. That's how the inductor functions. The best part about the inductor is there is no moving part. It's only physics used and created a vacuum, created a high pressure and a low pressure. And the wind always blows, as we know in the isobar charts, weather charts that we look at it, the wind always blows from higher pressure to the higher isobar to the lower isobars, higher pressure to the lower pressure. Same thing is happening. Certain amount of, there is a flow of liquid which is known as driving force, which is coming from the pump. This side is connected to the slop tank. Your slop tank is filled till certain level. You take suction from the slop tank to the pump and then put it on this line, and it goes back to the slop tank. You're circulating the cargo, circulating the oil from the slop tank, and it's passing it through this pipeline and going back to the slop tank. Just imagine there is no small diameter line, it's just a pipe. And we just take a suction, we fill this slop tank to a certain level to be used for inductor. and we use the pump, take suction from that particular tank, and through the pump we put it on this pipe and goes back to the same. We're just circulating the cargo. Now we reduce the diameter here. When we reduce the diameter, what will happen? The same amount of water which is flowing through at certain speed, same quantity has to pass through the smaller diameter pipe. What will happen? As the diameter is reduced, the speed will increase, so that the same quantity which is here can pass through this smaller diameter pipe at the same time. Time is same, quantity is same. So to cope up, the speed has to increase. So the speed of the fluid will increase. Same thing happens when you must be very much aware of the squat in navigation. Squat is also happening because of that. What is happening in the squat also? All of a sudden, there's a ship passing by. There is a smaller, the distance from the keel to the bottom is reduced. As the area is reduced, the depth is reduced, the current here, the flow of water here, the depth was quite okay, has to pass through the same area to the other side. Flow of current is there. So what happens when the same amount has to pass, the speed will increase under the keel. The flow of water increases under the keel, between the keel and the bottom. As the pressure increases, as the flow increases, speed increases, the low pressure is generated. When the low pressure is generated and there is a high pressure from the ship squats. Same thing is happening here. There is a flow of liquid here. Certain flow is there. Same flow is here also. Some quantity is passing. Same quantity has to pass through the smaller diameter line. When this is passing from here, the velocity will increase. So that same quantity reaches here. So when there is a increase in the speed, and if I put a pipe here and put a valve on that pipe and keep that valve shut, there is no flow of any liquid here. That means there is a high pressure here, there is a low pressure here. The wind will flow from higher pressure to the low pressure. Since there is no air here, no liquid, I kept the valve shut. As there is nothing to flow, the vacuum will be, but it will keep sucking, because the pressure is more here and pressure is less. Something has to move from here to here. As there is nothing to move, the vacuum will be created. As the vacuum is created, as soon as I open this valve, the liquid from the tank will be sucked by this, and negative pressure is created. All of a sudden, as soon as I open this valve, there is a high pressure here, there is a low pressure here. The wind will start flowing from there, and vacuum, the oil, whatever is there, will flow from higher pressure to low pressure, and the tank will be stripped or become empty. That's how inductor functions. Very commonly used, inductor system is very effective. No moving parts, easy to strip the tank these days. Because of the double bottom, as we said, we have a double skin all around the cargo area. What they have done, all the strengthening, all the longitudinal, all the transfers are on the ballast tank side. The cargo tank looks like a room, no obstructions at all. Plain wall, maybe a corrugated bulkhead, but no obstructions at all. The bottom is like a flat, no longitudinal inside the tank, inside the cargo tank, because all the stiffening is done on the other side of the plate towards the ballast side. They have made a well also inside the cargo tank, on the after side of the tank, where all the oil is flowing and getting accumulated air, and the bell mounts are inside the valve. So the stripping system has become very effective by this change in the constructions of the tank. All longitudinal, all the transfers are on the ballast side of the bulkhead, not on the cargo side of the bulkhead. The cargo tank looks like your room, plain walls, plain bulkheads, plain at the bottom, maybe some stiffening on the deckhead, on the tank top. But all other sides, all the other bulkheads and the bottom is flat, like your room. So it's easy there's no clinkage, very little clinkage in the tank. There's a free flow of oil. If you give a stern trim, oil is flowing easily, as there are no obstructions for the flow. And they have provided a well also towards on the after side of the tank. And all the bell mounts, stripping bell mounts and the main bell mounts are inside the valve. You can literally make the tank dry, because the construction is also advantageous, giving advantage to the ship, and you have in addition to that, you have a inductor system for stripping the tank. Very effective. You can literally make the tank dry. And the stripping line which is used, a smaller diameter pipe, as we saw it in that. These are the stripping suction and these are the main suction. The stripping suction, you have a valve here. Both are immersed in the valve. So all the oil from the tank is flowing, give a stern trim, flowing to the valve, and there's a small kind of a tub, you can say, within the tank itself, and the oil is flowing into the tub, and you have these bell mouths inside those tubs, which is used for stripping. It becomes very easy. No clinkage, no obstructions, no stiffening. All stiffening is on the ballast side, on the other side. So that has brought a big advantages in stripping the tanks. The out and figure of the ship has literally improved by changes in this in the construction and having a proper stripping system installed. Many ships have 2 ductors instead of 1. Very effective. So these days operation on tankers quite simple compared to what we used to have earlier when we had a single skin vessel. All the longitudinal transfers, all the stiffening was in the cargo tanks. It used to be very difficult to strip the tanks. Okay, these are the pipelines, and other than this, you have crude oil washing line, you have MAPO line. Also installed crude oil washing lines are used for crude oil washing the tank. The crude oil washing line can also be used for tank cleaning, and MAPO lines are used for discharging the last bit of after draining last bit of cargo, so that in the pipeline can be so that all the pipelines can be drained, all the pumps can be drained, and last bit also can be discharged as shown. And main stripping system is used as a inductor on most of the ships. So these are the pipelines which are used on ships. Any questions in exams are usually asked. Draw the diagram for the ring main, advantages and disadvantages of the direct system, compare direct system to the ring system, explain how the inductor function. So basically draw the diagram, learn how to draw these diagrams. You must know, you're expected to know, and the disadvantages and advantages involved in that. Okay, any question?
No, sir.
Okay, that's a good answer. All right, we end it here, guys. And now with you people, almost everything is complete. We will next lecture we will have deck seals and PV breaker. All right. Thank you, everyone.
Okay, sir. Thank you, sir.
Thank you so much.